So in graphing the sine and cosine functions, we want to really look at the unit circle to find our 5 key points. So our unit circle is a circle at unit 1, and the 5 key points are the points that are on the quadrantal angles. So at 0 degrees, pi over 2, pi, 3 pi over 2, and then back to 2 pi, which is going to be on the same. It's coterminal to 0. Now our points are going to be 1 comma 0 because it's over 1 up 0. This is going to be 0 comma 1, negative 1 comma 0, and 0 comma negative 1. Remember, this is a unit circle, so this distance is equal to 1, 1, 1, and 1. Now what we know is that the cosine function, the cosine of the angle, the cosine of x, is equal to this x coordinate. So this is equal to the x coordinate. And I know that the sine of, well, let's say theta instead of x, so it's not confusing. So then the sine of theta being the angle is going to be equal to the y coordinates. Now we're allowed to really call these things any variable that we want. So when I start graphing these things, I'm just going to call this variable x. I'm going to say y is equal to the cosine of x, y is equal to the sine of x. So if I want to graph y is equal to the cosine of x, x being the angle theta is what I mean by that. We know that it's going to be the x coordinate. So if we're looking at the 5 key points, you're going to have the angle 0, the angle pi over 2, pi, 3 pi over 2, and then finally back to 2 pi. Now the output of this function is going to be, it's going to be the x coordinate on each one of these points. So for angle 0, we're going to have output of 1. Angle pi over 2, it's going to be output of 0. Pi output of negative 1, 0, and then back to 1. So we're using the x coordinate of these points for this output. So now when I graph this function, I'm just going to graph one cycle. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. I know that we're going to go from negative 1 to 1. So it's going to be 0 comma 1, pi over 2 comma 0, pi comma negative 1, back to 0, back to 1. So we can see that the cosine function is going to look like this. So again, this is angle 0, pi over 2, pi, 3 pi over 2, and 2 pi. And this is output 1, output negative 1. Now, it repeats itself over and over and over again. So the pattern is consistent through this. So, it's going to continue this way, and it's also going to continue this way forever. You can find their inputs and outputs because you're just using the same coterminal angle. So most of the time we only say, let's just look at it as one cycle because the cycles are just repeated through the x-axis, or the angle axis is kind of what we're talking about. Now, if I want to do the sine of x is going to be very, very similar. So we're going to use the exact same angle. So if I change this to the sine function, the sine of x, the thing that's going to change is the output values are going to change because the sine function uses the y coordinates. So the y coordinate being 0, 1, 0, negative 1, back to 0. So 0, 1, 0, negative 1, back to 0, which means that this is going to change our graph slightly. So 0, pi over 2, pi, 3 pi over 2, 2 pi. We're going to have similar inputs and outputs, 1 and negative 1. But now we're going to graph 0 comma 0, pi over 2 comma 1, pi comma 0, negative 1, back to 0. So we can see that the sine function looks like this. And similar to the cosine function, this will continue forever and ever in both directions, but we usually just want to look at one cycle. So when I graph, I'm just going to do one cycle because I know the cycles are going to be repeated. Now that we have the parent functions for sine and cosine, we can do transformations. So we can stretch it, we can compress it vertically, we can stretch it, we can also compress it horizontally. And that's done by putting constants in the front of the cosine function or the sine function or in front of the angles. So what we want to do is we want to be able to graph these vertical and horizontal, we'll say stretch / compressions. So we're going to look at two functions. You have y is equal to a cosine of bx, and also y is equal to a sine of bx. And the a and b will do very similar things to both these functions since we know the parent function, both sine and cosine. So if a is greater than 0, then so when a is greater than 1, we know that we're going to have a vertical stretch. And when 0 is less than a, which is less than 1, we're talking about a vertical compression. Similarly, except opposite of what you think, if b is greater than 1, we're talking about a horizontal compression. And if 0 is less than b, which is less than 1, we're talking about a horizontal stretch. Now it can get confusing to students because why is it backwards for the transformations on the y coordinate as opposed to the transformations on the x coordinate? Well, remember that functions are solved for y. So transformations on the y values are kind of what you expect. That bigger than 1 is going to stretch it. If I multiply it by a proper fraction, it's going to compress it. Now, if we were able to solve this for x, we'd have to send everything to the other side. So if this set bx, the last thing you're going to do in order to solve for x would be divide by b. So that's why x's are opposite what you think, that being greater than 1 gives you actual horizontal compression, and being a proper fraction actually gives you a horizontal stretch. So what I want to do is I want to graph a couple of these. So let's graph y is equal to 3 sine of x over 5. Note that this is the same thing as 3 sine of 1/5 times x. Our function was 0, 0, pi over 2, 1, pi, 0, 3 pi over 2, -1, and then 2 pi, 0. Again, remember just the quadrantal angles and then the y coordinates. Now, what we have to do for the x transformation is this is going to be a compression of 5, which really means that this is going to be a stretch of 5 because this is a proper fraction, which really means I'm going to have to multiply all the x values by 5. Remember, x's are opposite what you think. If it's a proper fraction, it's a stretch. So I'm trying to think about this way. If I was going to solve for x, just kind of cover up this. If I was going to solve x over 5 or 1/5 x for x, I'd have to multiply by 5 in order to do that because this is solved for y, not for x. So I'm going to multiply all the x coordinates by 5. So 0 times 5 is still 0. This times 5 is going to be 5 pi over 2, 1. This times 5 is 5 pi, 0. This times 5 is going to be 15 pi over 2, -1. And this times 5 is 10 pi, 0. Now, that's for that horizontal stretch. Now, this is also a vertical stretch because y's are what you think. When I multiply by a number bigger than 1, it's actually going to stretch the y coordinates by a factor of 3. So I'm going to multiply all the y values by 3. So this is 0, 0 times 3 is still 0. 5 pi over 2, this will be 3. 5 pi, 0 times 3 is still 0. 15 pi over 2, this times 3 is -3. And then 10 pi, this times 0 is going to be still 0. So now when I graph this, graphing my we're going to have angle 0, 5 pi over 2, 5 pi, 15 pi over 2, and 10 pi. And then we're going to go up 3 and also down -3. So when we graph this, it's going to be 0, 0, 5, 2, back to 0, -3, 10 pi. So this is our single cycle for that sine function. One more. So of this form. So I want to graph y is equal to 1/2 cosine of 7x. Now again, the parent function for cosine is going to have angle 0, pi over 2, pi, 3 pi over 2. Remember, we're clicking basically 90 degrees around the circle for pi over 2, and then the 2 pi. And now we're going to choose the x coordinate. So the x coordinate being 1, 0, -1, 0, back to 1. And now I'm just going to do this in one shot. I'm going to take care of the x's first and then the y's second because I know that they're done individually. So what I'm going to do in order to solve for x's, I'd have to divide all the x's by 7 in order to solve 7x or 7. So divide all the x's by 7. 0 divided by 7 is still 0. This is going to be pi over 14. This is going to be pi over 7. This is going to be 3 pi over 14. And this is going to be 2 pi over 7. And then what this is going to do is multiply all the y's by 1/2. So 1/2 times 1 is 1/2. 0 times 1/2 is 0. This is going to be -1/2. This would be 0. And this would be 1/2. If you wanted to flip this over the y-axis as well, instead of having 1/2, if I did a -1/2, what it's going to do is it's going to multiply all of the y coordinates by -1. And what that would do is that would switch all the signs of these. 0, -0 is still 0. This would be positive. This would be 0. And this would be negative. So what that'll do is also flip it over the x-axis. So it's a deflection. So now when I graph this thing, we know I have 0. This is going to be pi over 14. Pi over 7, 3 pi over 14, 2 pi over 7, and we are going to go just a half. So this is 1 and -1. We're only going to go a half. So this is going to be -1/2, and then 0, 1/2, 0, -1/2. So you can see that this is that reflection and the compression in the y, and also a compression in the x by 7. So the last form that we're going to talk about is when we have a horizontal shift included as well. So this plus c on both of these ends. So if b over c is greater than 0, we're talking about a shift left. But if b over c is less than 0, then we're talking about a shift right. So what I want to do is I want to graph something of the form y is equal to 2 cosine 3x minus pi. So back to our parent function again. We know that cosine, again, angles. Every pi over 2. And the cosine is the x coordinate, so 1, 0, -1, 0, 1. Now, in order to solve for x, what you'd have to do is you'd have to add pi and then divide by 3. And that's what's going to make it shift, in that right direction. So adding pi first is going to be pi. So that would take care of that pi. And then I still have to divide by 3. So divided by 3 is going to be pi over 2, 3 pi over 6, 2 pi over 3, 5 pi over 6, and this is going to be 3 pi over 3. Now, we'll leave the y coordinate alone for right now.